Kia ora koutou. In this video, I'm going to go through two questions from the 2021 integration paper. So that's question 1D and 2E. The first one is the one about the water tank leaking, and the second one is a graphing one where we're given a differential equation. Okay, so I think neither of them is too bad, so that's why I'm going to combine them into one video. So let's look at 1D first and just read it through slowly. So we've got a water tank that developed a leak. 6 hours after it started to leak, the volume was 400 litres. So we know that V at 6 is equal to 400, and we're working with a function volume depending on time. And secondly, we're told that after 10 hours after the leak started, the volume was 256 litres. We have to form a differential equation from this information here. The rate at which the water leaks out of the tank at any instant is proportional to the square root of the volume of water in the tank at that instant. So we can write down the following dE. It's going to be dV by dt is equal to K times the square root of V. And we know that K is going to end up being a negative number because the volume is decreasing. Or the other way you could write it is you could just have this be negative K root V. It doesn't matter. Okay, so I've chosen to do it this way. How much water was in the tank at the instant it started to leak? So what we've got to do is figure out an equation that gives us V and then find what V was when T equals 0. Okay, so just working down here, let's go back to the start. So dV by dt is equal to K root V, and K will turn out to be a negative number. So we're going to separate the variables and then integrate both sides. So this is just the usual. So 1 over root V dV is equal to K dt, and integrating both sides is the next step. So here we've got V to the negative half dV is equal to KT plus C. Integrating this gives me V to the power of 1/2 times 2 is equal to KT plus C. Now we've got two bits of information. We know that when T is 6, volume is 400, and when T is 10, volume is 256. We're going to substitute each of these points in and solve to get K. Okay, and this is nice because both of these square root without a calculator. So 2 times the square root of 400 is equal to 6K plus C. 40 is equal to 6K plus C. So that's my first equation. And now I can do the same thing using T equals 10. So 2 times the square root of 256 is equal to 10K plus C. That gives me 32 is equal to 10K plus C. So there's equation 2. And we just need to solve those. So equation 1 take away equation 2 gives me 8 is equal to negative 4K. So we get a K value which is negative 2, and as expected that's a negative number. Now we need to chuck that back in here and solve to get C, and then we're just about finished. So 32 is equal to negative 20, 10K, plus C, giving me C is equal to 52. Let's go right back to the start now and get this written out with specific values for K and C. So we have 2 root V is equal to negative 2T plus 52, and when T equals 0, what have we got? Well, 2 root V is equal to 52. Root V is equal to 26. So V is equal to 26 squared, which is 676 litres. Okay, so that's question 1D done. I'm going to move on now to question 2E. Might have an interruption from the dog. We'll see how we get on. But let's read it through first. Okay, so the diagram below shows us the graph of a curve, y is equal to f of x, and that's come from this differential equation here. Points P and Q are the points on the graph that have an x coordinate of 3, and we have to find the vertical distance between P and Q. So that's that distance there. So what are we being asked to do? Well, really, all we have to do is to find the value of y here, which is when x equals 3, and then double that length. So PQ is going to equal 2 times, call it y naught, if you want to be complicated about it. All right, so we're going to take that differential equation, separate the variables, and see where we get to from there. So the d that we're starting with is this dy by dx is equal to 2 over y times e to the 0.5x. Separating the variables gives me this y dy is equal to 2e to the negative 0.5x dx, and I'm going to integrate on both sides. So on the left-hand side of the equation, I get 1/2 y squared, and on the right-hand side, I'm going to get something times e to the 0.5x. So just working backwards, I need to be dividing out by the negative 1/2, so this is going to give me negative 4. I'm doing this quite quickly because I'm figuring it's the end of the year. If you're watching this, you should be really confident with backwards chain rule by inspection. So I haven't taken too long on that, and we need our plus c, and I'm going to put that in on this side. You can work with it with the half y squared, but I times everything through by 2, and that gave me y squared is equal to negative 8 e to the negative 0.5x plus, now 2c we can think of as just another arbitrary constant, so you can call it c dash if you want to. Right, so look back at the graph and see what we know now, because we need to pin down this value of c. So going up to the graph, we can see that at x equals 0, y is either equal to 1 or negative 1. So we'll substitute in one of those values. So let's substitute in 0 and 1. We get 1 squared, so 1 is equal to negative 8 times e to the power of 0 plus c. So 1 is equal to negative 8 plus c dash, or c, giving us 9 for the value of that constant. That tells me that y squared is equal to negative 8 e to the negative 0.5x plus 9. Okay, so we've got down to here, so that's good. Right, the next thing that I need to do is to figure out what the y value is when x is equal to 3. So y squared is equal to negative 8 e to the negative 1.5 plus 9, giving me y squared is approximately, I went to quite a lot of DPs on this, so 7.21496 is what I used. So y is going to equal positive or negative 2.686. So we can mark that onto our graph. So this point here has coordinates 3, 2.686, and this one down here is 3, negative 2.686. So we want the vertical distance between those 2 points. Just scrolling back down here. So distance PQ is equal to 2 times 2.686, which is 5.372 units. So there you go, that's the first 2 excellence questions done. I'll try and work my way through the rest of the level 3 papers over the next few days, but we'll see how we go. Thanks for watching, and let me know if there are any mistakes in here or you've got any questions. Just leave me a comment and I'll try and get back to you.